Hi everyone, welcome to our fantastic stroke project. I hope you're doing well recently, including this project or final exam as well. So our group started with me, Cesar Lorento, and Pranjal Patel. And our project is about the stroke using quantitative methods. So before we go through our project, we just need to announce about our change of the topic. Because the previous data did not have quantitative value so that we cannot do any analysis like t-testing, linear regressions, we need to change the data from previous topic, Jeju beer, to the stroke.
According to the World Health Organization, stroke is one of the main causes of death, responsible for 11% of the deaths globally. And so, with this data set we're going to use, we have 5,110 entries and 12 attributes. Our objective is to identify which variables cause stroke. And in order to understand the data, we're going to visualize it through graphs to show distribution and distribution of population and frequency of variables. And so our actual analysis is going to include three things, which is hypothesis testing, linear regression, and Pearson chi-square.
For the analysis of the data, we are going to use data visualization techniques, so use of different graphs and the techniques of hypothesis testing. So for data visualization, the first shows the living condition of the population. So what age group they are, what is their marital status, which work sector they work for, whether it's a government, semi-government, or private, and the place of residence, whether it's a rural or urban. The next slide, this four graph shows the medical condition of the population. So whether the population, a majority of the people, they have hypertension, if they have any history of heart diseases, what is the obesity condition, and if they have a history of heart stroke. Now for the hypothesis testing, we're going to test for two parameters, that is the body mass index and the glucose level of the population. The null hypothesis for both of the cases are that the population is healthy. So for BMI, we take a standard value of 25. So if the value is less than 25, the population is healthy population, and if the value is more than 25, then they fall into overweight and obesity condition. For the blood sugar level, 140 is the division mark. So a blood sugar level of less than 140 is considered to be healthy, and a blood sugar level of more than 140 leads to pre-diabetic and diabetic conditions. For the hypothesis testing for the blood sugar level, since we do not have the population mean and standard deviation, we are going to use the sample mean and standard deviation. So we are going to use the t-stat value. For blood sugar level, the sample mean came out to be 106.14 and the standard deviation as 46.22. Mean value that we are considering is 140. So the t-stat value that we got here is minus 50.2 and the degree of freedom is 5109. From that we got a p-value of 1. Since we are considering alpha value of 0.05 and p-value is greater than alpha, we failed to reject the hypothesis. For the body mass index, we got a mean value of 28.89 and a standard deviation of 7.85. Mean value in this case we considered as 25, and the t-stat value that we got from our calculations was 35. The degree of freedom here is again 5.09, and the p-value that we got is significantly small. It's 5.4 into 10 power minus a great number. So the p-value here is less than alpha, and so we reject the null hypothesis that the majority of population is in fact in a healthy BMI range.
With data visualization and hypothesis testing with t-testing, we can understand what is our data and how it looks like. The next step is linear regression. The purpose of linear regression is to find a known pattern and predicting the chance of the stroke based on some conditions. And there's several attributes, and we divided it to two variables, which one is x variables, the other is y variables. So x variables is that it's that cause something, and y variable is caused by x variables. So first, we did the linear regression with only x variables, because if we can find something meaningful result from here, in the future, we can do chi-square test easily. But to be honest, there's nothing that we can get any meaningful result. As you can see the tables there, maximum R squared value was 0.163. It means it's hard to say that age and BMI has a relationship. And as you can see the residual plot and 3-line fit plot, also it's hard to say there's any patterns between the variables. And that orange graph is almost parallel with the x-line. And next one is our main linear regression between x variable and y variables. And same as the x variable analysis, the maximum value of R squared is 0.058, which is lower than x variables analysis. So it's hard to find something from linear regressions. And as you can see the residual plot and line graph, that graph say nothing to us. The reason of this situation would be two. First one is that there's no sufficient number of data so that this linear regression doesn't work for this data. Or, in fact, there's no any other relationship between these variables.
For chi-square testing, it's in progress. We have some assumptions. And so we think that stroke is directly correlated with obesity, hypertension, and age. But also we're going to be aware of misleading results, such as married patients that are more likely to have a stroke. Our expected results are to get a correlation between the factor and the chances of a stroke for a person. Our further scope is to have a reference number of glucose level and body mass index to predict the chances of stroke. This is all for today. Thank you for your attention. Have a good day.